So this problem asks us to calculate an integral, which is area underneath a graph. And remember, our goal is to use fundamental theorem of calculus, right? I want to find an antiderivative of this function and then plug in the two numbers. So it doesn't matter how you find the antiderivative. You can literally guess the antiderivative, and as long as it's correct, right? But sometimes we have to use substitution rule to kind of help us along. So do you have an idea of maybe how to do that with substitution rule? Because I don't know a function right now. I can't think of a function right now whose derivative is that, right? It's not in my repertoire of rules, right? Like it's not like sine x or cosine x or x squared. It's not one of those simple functions.
Can we make u 1 plus e to the x?
Good. Now, why would you choose u equals 1 plus e to the x? Can you explain that in terms of what we've talked about with like, rules of thumb and stuff like that?
If we take the derivative, it could cancel the numerator to the top and the bottom.
Good. So the derivative of u is e to the x, and that actually is sitting right outside multiplying the whole thing. So like Maitri said, when we do the translation, it should cancel out. Okay, so let's actually do that translation. Okay. And I've taught that we should solve for dx, right? So we get what? Du over e to the x. Good. And now we translate. So the e to the x, I still don't know what to do with. The 1 plus e to the x is u, and the dx is du over e to the x. So the e to the x's cancel out, and I'm left with 0 to 1, 1 over u du. Now, does everyone agree with this? Are we good? And the answer is ln of u. But I tricked you. There's a mistake. So I asked you if you all agreed with this, and you all said yes, but there's a mistake. So where is the mistake? Okay. Don't we change the limits? That's right. So the mistake is I kept the same numbers, 0 to 1. Notice in this case, this particular problem, that should have actually kind of screamed out at you a little bit, because if you look at this, 1 over u, if I'm starting at 0, that's a problem, because 1 over u looks like this. Starting at u equals 0, this function isn't even defined at u equals 0, right? I mean, this type of integral is what's called an improper integral. You would talk about that in calculus too, but in this class we definitely haven't. And so this should actually scream out at you, wait, something is wrong. That 0 shouldn't really be there. Okay, in fact it shouldn't, right? Because we forgot to change the limits. So these limits are incorrect. Let's add that to our translation table. That's sneaky Dr. G. So we originally had x equals 0 and x equals 1. The question was, can you keep the limits and then rewrite in terms of x? Well, not really, because if you were to write 0 and 1 here, that's still incorrect, right? I mean, if you want to write, say, x equals 0, I mean, that's okay. And then take the antiderivative, ln u, x equals 0, x equals 1, and then put back what x is. I mean, that's fine, but again, you're just undoing your work, right? Why go back to u, keep the old numbers, and then go back to x, right? Just change everything at once, right? But yes, you are right. You could keep the numbers, but make sure that if you do keep the old numbers, you make it clear that those are the old numbers, right? That you actually write down x equals, not u equals. If you don't write this x equals, it's assumed that those are values of u, and that's definitely incorrect because 0 isn't even defined for this function, right? Okay, so going back to the limits of integration, x equals 0, that means u equals, let's see, 1 plus e to the 0, so 2, and 1 plus e to the 1, so 1 plus e. So the limits are 2 to 1 plus e. Now we get our antiderivative, which is ln of u. I don't need absolute value because notice all the numbers are positive, 2 to 1 plus e. That's a positive interval, so I don't need the absolute value. So I get ln of 1 plus e minus ln of 2. That's it. Questions about that? If not, I'll do Victoria's question. Yeah, you can leave it like that. How else would you like to leave it? There's no way to simplify this anyway. I mean, that's it. Right? The ln doesn't distribute. Like you don't get ln of 1 plus ln of e. That does, ln is a function. It doesn't distribute like that. Oh, yeah, sure. You can write it as you can combine the two using logarithm rules if you want. I don't necessarily think that's simpler, but that is perfectly fine. You could do ln of 1 plus e over 2, right? A difference becomes a quotient.